Hello everyone, welcome to my channel. I am Zhibo. A little bit about myself. I did both my bachelor's and master's degree at the University of Toronto. During my bachelor's study, I finished 3 programs: computer science specialist, statistics major, as well as mathematics minor. During my master's study, I did machine learning research, collaborating with algae AI research. 2 things I find mostly enjoyable during my graduate school. The first is, of course, machine learning research, discovering all kinds of exciting things that is state-of-the-art. The second perspective, which is also fun, is about teaching. So I taught tutorials for several computer science and statistics courses at the University of Toronto as a teaching assistant. So luckily, I find out that students like my teaching. So I was thinking, why don't I open up a channel and share the machine learning knowledge with a broader range of people? So here it is. So today, we will go through a brief introduction on what machine learning is. So people have been talking about machine learning almost everywhere. But is it really that magical? If you ask me to summarize machine learning in a single sentence, I will tell you that machine learning is all about function approximation. So what does it mean? Let's dive into it. Suppose I have some data, some input data, for example, some images, right, that represents like cats or dogs, and they're coding labels. So labels is something that we care about, and we may try to predict, right? It could just be some categorical values, a cat or dog. So what machine learning is doing is that it tries to fit a function or a mapping between the input x and the output y. And we denote this function as f, okay? So given an input x, we fit it into the function mapping f, and then the function mapping will output fx. So that's basically what machine learning is all about, right? Right now, we don't really care what the function mapping specifically is. It could be any sorts of things, right? It could be something as simple as an identity mapping, right? Or it could be something as complex as a deep neural network. Right now, there is no need to really figure out what the mapping is, but just know that machine learning is trying to fit a function between the input and the output. And that's it. So there are 2 ways to categorize machine learning algorithms. Okay, so the first way is we can categorize the machine learning algorithms through their output values. So the output values, where there could be regression-based algorithms or classification-based algorithms. So for people who have exposed themselves to statistics before, they probably have heard about the term linear regression. So linear regression is something that, for example, we have x and y axis, and we have a bunch of data. For example, this could be some simple time series data, right? The temperature changes along the timeline. So we want to fit a straight line to check if for example, linear pattern matches the data point well. Okay, as we can see, the output values, they can be along the range of real values, right? They can just be something as real values, and it's continuous, right? It can be anything. So here, this one is continuous. And classification, okay, in contrast, is something that outputs a discrete value. So the output is discrete. For example, if we have two classes of the input images, the cats or dogs, we want to assign each input image into one of the two categories. Right? One simple application is what I have been talking about is image classification, where you want to assign the input images to their own categories. There are other things as well, for example, like image segmentation, where you want to detect the part of the object. So in order to do this, you assign each input pixel a classification value, okay? Whether, for example, it is background or the object itself. So image segmentation. Or there could be, in the natural language domain, there could be sentiment analysis, where the input would be some natural language sentences, and the output is kind of a rating, for example, between 1 and 5, in order to detect whether customers are happy or not about the service. Okay. Of course, there are other ways to categorize machine learning algorithms. Another popular way is to decide how much amount of supervision or what type of supervision they receive. Okay, so supervision is something that, for example, if you do a graduate degree, right, you have a supervisor, and the supervisor kind of guides you towards the direction, right? Or when you were children, right, your parents will tell you that something you do is right or wrong. And when you are a student, you do some practice questions, and each question have an answer, for example, which is correct or wrong, right? That is kind of a supervision. So supervision is telling you that you are doing the right thing or the wrong thing, and you should try to correct yourself if you are on the wrong way, right? So based on that, we have mainly four types of algorithms. So first one, as we have discussed, is supervised or fully supervised learning. Okay, so for each data instance, for example, in the image classification domain, right, each image is associated with a particular given label. For example, for each image, we know this is a cat or this is a dog, and the computer will know that when it tries to learn a model themselves. Okay. Or there's could be like semi-supervised learning, where the label information is partially available, right? For example, in a lot of real-world scenarios, there are a ton of data instances out there, but we don't necessarily have the resources to label all of them. So instead, we can just ask some human being experts to label partial data, and then use some partial data to kind of give a little bit of supervision inside the learning process. Obviously, there is also unsupervised. Okay. Very hot direction or very hot trend recently is self-supervised. And one last direction is called reinforcement learning. This is a more complex one, and the least, I'm not going to say it's the least mature direction, because there's also a lot of state-of-the-art papers in that area, but it's more complex in the sense that it involves the model to interact with the environment, and the environment in turn will give it a feedback called a reward. So there's no correct or wrong here. It's only about how good your prediction is. Okay, and you want to maximize the long-term reward. So that is reinforcement learning. So we can give some videos about reinforcement learning in the future as we gradually build up the foundation. Okay, so that's pretty much it for today's video. So one critical takeaway that you could learn from this video is that machine learning is just simply function approximation. It tries to map the input to the desired output. Okay, so that's what the magic is all about. Thank you for watching, and I hope to see you all in the successive videos.